Okay, here I've got to do two things. I've got to do a show that these lines intersect. So at some point I'm going to be saying, therefore the lines intersect. But I've got to do a bit more than that. I've got to find the position vector of their point of intersection. Okay, so actually, even if I only had to do the first part, I would try and do the second part. So I'm going to try and make these two lines intersect. Okay, now these lines are given in the form r equals, okay, but remember that r is always replaceable by x, y, z. Okay, so x, y, z for the first line, okay, equals 3, 5, 1 plus some value of lambda times 2, 3, 4. Okay, and x, y, z for the other line is given by this recipe. But if they intersect, okay, so at the point of the intersection, if there is one, all right, the two points that are generated, the x, y, z's, have to be the same outcome. So if this is the point of intersection, there is a lambda that I can shove in that generates that point. And there has to be a mu that I can shove into this one that generates the same point. So I need to be able to get the same answer by doing 116.7 plus some value of mu times 4 minus 1, 3. So the question becomes, is this possible? Okay, and if it is possible, okay, what is the point? And this all comes down to saying, well, is there a value of lambda and a value of mu that I can use that will make this work? Now, it's got to work for x, it's got to work for y, and it's got to work with z. So potentially that gives me 3 different equations I can set up, but there are only 2 unknowns to find. Now, this situation is simultaneous equations, okay, but you only need 2 equations to find 2 unknowns. Okay, so the 2 you normally choose are the x equation and the y equation. Doesn't mean we're going to ignore the z equation. The z equation has got a different job, which we're coming to later. So let's set up the x equation. 3 plus 2 lambda equals 1 plus 4 mu. So what I'm doing is you're allowed to look at just one row of this whole equation at a time, taking into account these multiples of lambda and mu. So the x equation was that. So the y equation is going to be, y implies that 5 plus lambda times 3 is 3 lambda equals this 16 minus mu. Okay, and we'll ignore z just for now. We'll come back to it later. So this is simultaneous equations. Okay, now you can solve these using the GCSE method of elimination. So one approach to do it would be to multiply this one here by 4 and then add the 2 equations and the mu's will be eliminated. And if you want to do it that way, that's fine. Okay, I quite like doing it that way. However, you might like the idea that your calculator in equation mode, you haven't sussed this out already, your calculator will solve simultaneous equations. Okay, we're going to have 2 unknowns, lambda and mu. So I need to have, they're using x and y instead of lambda and mu. I need to have the equations in the form something times lambda plus something times mu equals some number. Where those noughts are, I'm going to change them into the letters. So if I rearrange them, okay, the top equation is going to become, well, I'm going to have 2 lambda. Okay, but I need the mu's to be on the same side, so I need to subtract 4 mu. And then I need all the numbers to be on the other side, so I've got 1 already, but I'm taking away this 3 to get rid of that. So my first equation is going to be 2 lambda minus 4 mu equals minus 2. And rearranging the second one, I've got 3 lambda there. With the mu, I'm going to have to do plus mu equals 16 minus 5 is 11. So I've done a little bit of work there so that I can be lazy now. Okay, so if I now type those in, so the top equation, 2 is going to be x minus 4, it's going to be y equals minus 2. The calculator insists on x's and y's. Get it in the light so you can see it. So it is 2x, so I press equals to get to the next one, minus 4. So I need to use that minus and then 4 times y. That's saying 2x minus 4y equals minus 2. Okay, and the second equation was 3 lambda plus 1 mu. Oops, I pressed equals too many times. Second one is 3 lambda plus 1 mu equals 11. Okay, so let's see if I can get that so that you can see it reasonably convincingly. Okay, you can't see the 11 very well. Oh, because it hasn't gone in yet. Okay, that is now an 11. Still can't see it very well. And when I press equals, it will tell me the value of x, but I've got to remember that x means lambda, so lambda it's telling me is 3, and press equals again, it tells me that y is 2, so lambda is 3, mu is 2. Okay, so the calculator method for your simultaneous equations is okay, but you can do it by elimination in the GCSE way. All right, so I've got a lambda and a mu. Have I finished? No, I haven't. I haven't done either part of this question, but I've done all the hard work. What I was supposed to do is show that these lines intersect. I haven't done it yet. I found a lambda and a mu that are required if x and y are going to work, but in order for them to intersect, the z's have to work as well. So I promised you the z equation was coming. So what does the z equation tell me? Well, if I look at my z's, here I've got 1 plus 4 lambda. So 1 plus 4 lambda to make z work has to give the same answer as this side. 7 plus mu times 3 is equal 7 plus 3 mu. So I generate the z equation, okay, and now I'm going to try out my values of lambda and mu. So if we try lambda equals 3, then that means 1 plus 4 lambda is going to equal 1 plus 12, which is 13. And if I try my mu value, which is 2, I have to check works with this 7 plus 3 mu. So mu equals 2 gives me, don't know what this 3 is for, 7 plus 3 mu, okay, is going to equal 7 plus 3 times 2 is 6, which is 13. And the fact that these are the same, okay, all right, so our comment here is that z works, therefore the lines intersect. So now I've done part of the question. I've done the first part, which was showing the lines intersect. But now I've got to find the position vector of the point of intersection. So I now know a value of lambda and a value of mu, and both of them generate the same point. I haven't yet worked out what that point is. Okay, all I need to do now is take either the lambda or the mu, or if I feel like it, both, and use either this equation or that equation, or if I feel like it, both, to work out the point. So the point that I need, okay, the point is going to be x, y, z, and the first equation told me that x, y, z equals, it was 351 plus lambda times 2, 3, 4. There it was. 351 plus lambda times 2, 3, 4. But this lambda value, I now know that lambda should be 3. So I'm going to lob a 3 value there. Okay, and I'm going to get, for the x bit, I'm going to get 3 plus 3 times 2, which is 9. And for the y bit, I'm going to get 5 plus 3 times 3, which is 5 plus 9, which is 14. And for the z bits, I'm going to get 1 plus 3 times 4, which is 13. In fact, I have seen that 13 here. Okay, so my point of intersection, one last step, I should give coordinates rather than a position vector. So this is my intersection point, and I should be done. However, okay, although I could stop there, it's not a bad idea to just double check that when I take mu to equal 2, I do get 9 and 14 here and here. So with mu is 2, if I made this mu equal 2, then 2 times 4 plus 1 does equal 9, and 16 minus 2 does equal 14. So I'm even surer of my answer. But that is now a fully correct solution. So I hope that made sense.